Monday, Monday. I don't know if you've ever heard that song or not. It's an old one. All right, so what do we got here? Still working backwards. 77. Instructions say use the graphing calculator to graph the polynomial. Identify the x-intercepts, the y-intercepts, and the points where local maximums and minimums occur. So these are ugly things that you just couldn't do by hand. Although you can do some of it by hand. Like a y-intercept's easy. It happens when x is 0. So if I throw a 0 at this thing, that's a 0, that's a 0, that's a 0. The y-intercept happens to be at 0, 0. Now, since that's at 0, 0, I also have to know one of my x-intercepts. It's also at 0, 0. But to find an x-intercept, what we do is we let y be 0. So this is going to become a 0. I'm going to put that in y1, and I'm going to put all this crap in y2. I'm not saying this couldn't be done by hand. I'm just saying it probably can't be. So 0 in y1, 0.7x to the fourth, minus 8x to the third, plus 5x. So got to pay attention to what I'm doing here. Plus 5x into y2, zoom 6. There's your y equals 0 line. And there's your funny looking polynomial. It's got 3 x-intercepts. One of them I've already talked about. Second trace 5 to get them. Get close. Enter 3 times. Enter, enter, enter. There's your x-intercept. It's at negative 0.770. There's one more to talk about. Second trace 5. Get close. Enter 3 times. It's at 82 hundredths 0, so 0.820. Local maximums, that'd be that dude right there. Second trace 4 for max. Oh, notice I'm up in y1. I actually have to press the down arrow to get into y2. I get left, I press enter. I get right, I press enter, and I guess. It's at roughly 0.47, 1.55. If you haven't got yourself a TI-84 yet, you probably should. I don't know what else to tell you about that. Local min would be this dude right here. That's the bottom of a graph. Second trace, sorry, that's a local bottom of a graph. I'm going to take my cursor, put it in y2 first. I'm going to get close. I'll press enter for the left boundary, enter for the right boundary, enter for a guess. There's your minimum, negative 45 hundredths and negative 1 and 49 hundredths. Yeah, that's all it wanted. Notice, by the way, this thing had 2 turning points, but yet it was next to the fourth. All right, this guy right here, y-intercept's easy, 0, 0, 0. It's got to be a 2 left over. There's the y-intercept. I can't translate that into an x-intercept, so I'm going to have to replace this with a 0. Same thing, y1, y2. You doing all right tonight? I don't think you heard me. Zoom 6 it. Kind of a funny looking polynomial. We have 3 x-intercepts. Second trace 5. Get close. Enter 3 times. Enter, enter, enter. There was one of them. 1, 0. Oddly enough, I was going over here. Second trace 5 for my intersect again. Let me get that a little closer. All the way to the left. Enter, enter, enter. There she is. Negative 2.160. And the last one, all the way to the right. Enter, enter, enter. 1.750. You doing all right today?
Not too bad.
I can get all that stuff. All right, we got local max, local min. I'm gonna do the local min first. Second trace 3 for minimum. That wants that left belt, got to be in Y2. Left boundary, enter. Right boundary, enter. Enter for a guess. 1.46 and a negative 1.68. There's a maximum up here. I'm not sure I see it. I'm going to go after it, but I have a hunch my calculator will freak out. Got to be in Y2 again. If I get left, I press enter. Right, I press enter. And then I guess. Oh, it found it. I'm kind of surprised because that wasn't on the screen. So it's at negative 1.63 and 10.47. 75. The y-intercept is easy. I let those x's be 0. The x-intercept, I can get one of these by factoring. There's one of them. 0. Oh, it's right there. The other one's a little harder to do. It's the cubic root of 3. 3 times. So I already found the 0, 0. That right there is going to be the cubic root of 3. Second trace 5 for intersect. Enter, enter, enter. 1.44. You don't have a local min. Doesn't exist. There's only this guy right here, local max. Second trace 4 for max. Left, right, enter. Thank you, sir. 0.91, 2.04. And there's those 3, which you shouldn't have needed my help with. The only reason you would need my help is if you haven't gotten yourself a TI-84, and you probably should. 74 is analyzing. You are supposed to analyze the graphs below by estimating the coordinates of each turning point and state whether each corresponds to a local max or local min. Then estimate all real zeros and their multiplicity. Finally, determine the least degree. 74 has 1, 2, 3, 4 turning points, which means the least degree it can be, it is at least x to the 5th. All right. What else are we supposed to do? State whether each corresponds to a local max or local min. All right, so this is a local max. It's at negative 3, sorry, it's at negative 2, 0. Also happens to be a 0. It's a local min. There's one up here, it's about 1, negative 1, 2, which is a local max. Here's a minimum down here. I would say it's at roughly 3/2 negative. Boy, that is a horrible grid. Negative 4 1/4. I'm not even sure it's 3/2. That would be 1, wouldn't it? So it's at 75 hundredths, negative 4 1/4, or 3/4, and then negative 4.25. That's a min. And that's it. Okay, my zeros. I don't know why I didn't leave you enough room for turning points. There was, it got cut off. Oops, these were my turning points. My zeros are negative 1. It has a multiplicity of 2 because it's a touch. We call this a touch. Happens twice. All right, touches happen twice. I have a 0 at 0. X equals 0, right there. I have another 0 here at 2. By the way, that x equals 0 was a cross, and they happen at least once. This is also a crossing. It happens once. So this guy happened twice, once, and once. Now, how did I get that it's at least x to the fifth? Because the correct wording here is at least twice and at least once. At least once. This guy could have happened 1, 3, 5, 7, 9 times. 1, 3, 5, 7, 9 times. 2, 4, 6, 8. It's always about even multiplicity. So while on paper I only have 4 zeros, I know because of turning points it has to be at least x to the fifth. Wait a second, Milbrath's dumb. This is not a turning point. This is Monday, and I've had a Monday. It's got 3 turning points. It's at least x to the fourth. It's even behaving like x to the fourth. Starts high, ends high. 73, let's see if I can redeem myself on 73, has 2 turning points. 2 turning points, which means that it is at least degree 3. It's at least x cubed. We're supposed to estimate these turning points, or sorry, these maxes and mins. And I would say that this one is at about almost 1.5. I'm going to go with it for x, and a y value really close to 2. And who cares how accurate I am? This one is probably around 2.5 and negative 2. The zeros here are at 1, 2, and 3. They are x equals 1, x equals 2, and x equals 3. And they're all crossings. Every one of those is a cross. And that means they happen at least once. But so 1 plus 1 plus 1 is 3. They all have a multiplicity of 1. Multiplicity is 1, multiplicity is 1, multiplicity is 1. The big thing is they have odd multiplicity. And 72, the last one I'm going to do, and then I'm going to go home for the day. I have 2 turning points, 2 TPs, means at least x cubed. The coordinates of the turning points happen to be the maxes as the mins. So this is going to be 1, 0. That is a local max. This is going to be 3, negative 4. That's a local min. Your zeros are at 1 and 4. This one is a touch. Happens twice. Sorry, it happens at least twice. So this guy has a multiplicity of 2. And this crossing right here is a crossing. It is a legit crossing, which means it happens at least once. So its multiplicity is 1. If you take 2 and 1 and add them together, you get 3. So there is 72 through 77. I'd really like to go home. And I don't have enough time to do the ones above because they're graphing by hand, and I just don't want to do it. So there is it for the day. Till tomorrow. Wish I had something witty to tell you, but I'm tired.